exciting research and editorial activities, Dr. Bora continues to contribute to the advancement of applied mathematics and numerical analysis. Dr. Bora has delivered invited lectures and served as a resource person in academic programs, lecture series, and conferences. He played a key role in organizing international conferences, workshops, and faculty development programs. He also published an Indian patent entitled Solar-Based Automated Hydroponic System for Synchronous Growth of Vegetables using LoRa module, reflecting his engagement in interdisciplinary research and technological innovation. I invite Dr. Bora to
already one time you do it. Thank you very much for inviting me to this conference. Respected Chairperson of Organizing Committee, Professor Mudamangal Pal, and other guests and participants from different parts of the country and abroad, and my colleagues from the Bora University, research scholars, and all well-wishers of the conference. Actually, in my talk, I have basically considered the eigenvalue problem. You know, this eigenvalue problem is one of the linear algebra. All we are aware. So, classical eigenvalue, these things, this is well. Or is to find a scalar for satisfying the matrix equation Ax equal to lambda x, where is square matrix for some non-zero vector x. And this eigenvalue problem further extended to another category, generalized eigenvalue problem, where in the left hand side part we introduce another matrix Ax equal to lambda bx. There are many categories of eigenvalue problem, which are some categories are non-linear in nature and some are linear in nature. And non-linear, this problem, which is non-linear, having satisfying certain matrix equation, we call it non-linear eigenvalue problem. And the problem is considered the polynomial eigenvalue is a special type of non-linear eigenvalue problem. So there are certain physical problems where multiple parameters exist, and such case certain linear eigenvalue so there, which we are not considering here. So we are considering here a special category of eigenvalue problem of quadratic associated quadratic problem. So matrices are allowed to be rectangular rather than square. So this is a new category of problem. These are my content. And for polynomial eigenvalue problem, having square coefficients are well investigated in recent literature, but rectangular case, they are largely unexplored in literature. So here, matrix 1.1, we have taken the matrix polynomial of the form 1.1, and the matrix coefficients are Mij are the matrices of size m by n. The associated eigenvalue satisfying the matrix equation eigenvalue. So we can define the eigenvector in a similar way also by replacing x by x star on the right hand part of lambda mu. And most of the work in literature were carried out by considering the matrix polynomial with square coefficient matrix only. So, if any matrix polynomial of any grade with square coefficient matrix appear in many practical applications. So, one of the examples, the differential equation and arrow elastic photo problem. Some technical issues there. Okay. Okay. Okay, thank you. So, such type of mainly solved by two approaches. One, direct solution, and other is we will have to solve by linear into a special category of problem. One the approach is is converted from metric size to high dimension. That means certain connector product operation need to be exist, and that is why this dimension increases. So this is the drawback. But in direct solution, the another is matrix consisting of 5 matrix, large scale matrix, then it will not be computational friendly, and therefore we need alternate approach to address this problem. So one of the methods is the Jacob method, it is direct method, and homotopy method, this is also direct method, and fiber product homotopy method. This is actually indirect method where problem is converted to linear form, and fiber product based homotopy method is used to solve this problem. Okay. So, actually we have considered quadratic case because quadratic case can be considered as a continuing thread study the K-grade problem. That means we develop the method for quadratic case that it can be extended to develop of any grade case. So, in case of the spectral parameters lambda, they appear linear in the chart, and the matrices are of sizes n plus k minus 1 by n. That means here we have seen the size of the number of the matrices large, and such type of matrix is called tall matrix. Now, an intersection technique is found in the literature to solve this problem. So this I'd like to leave. And recently a new category of eigenvalue problem developed. This is represented by equation 1.4, where actually this omega, this is a multi-index and non-zero vector x. We'll have to find it. This is called eigenvector, and this coefficient matrices are rectangular in nature. So such type of problem appear in H to optimal reduction model in dynamical system. So these are the some preliminary notation we will use. So these are well-known notation. This Euclidean norm will be used in our further discussion. And this IMN, this represents a matrix consisting of identity matrix and zero matrix of appropriate order. And A to the power mn, here it is a block matrix consisting of coefficient matrix A of sizes m by n and zero matrix of appropriate order. So already we explained that that means number of row is greater than number of column, then such type of matrix is called tall matrix. And this is the primary assumption. This is definition 2.2, which will be exclusive in our linear. A linear matrix pencil of the form A lambda bit plus mu c of size 3m by 3n is said to be linearization of the rectangular quadratic two-parameter matrix polynomial if there exists two unimodular matrix U and V satisfying the matrix equation 2.1. Unimodular means this is the matrix having constant determinants. That means they are independent of lambda and mu. So next we use another concept which is called box addition of block matrices. So here consider we have taken example how to add box wise. That means we have taken three matrices x cap, y cap, and z cap, and after box addition, uh, it will become like this, and this plus is usual matrix addition. So already I explained that in case of rectangular single polynomial, the concept of generalized linearization is introduced. But therefore, this further for single parameter matrix polynomial, this concept has been already used. So therefore, further extension is required to develop the generalized linearization for matrix polynomial consisting of two parameters. But here we have considered the rectangular case also. So our aim is to present a linearization technique of rectangular quadratic two-parameter matrix polynomial and to investigate the vector space produced by the associated linearization classes and to determine the optimal square linear time invariant dynamical system and autoregressive moving average model from the associated eigenvalue problem. That means these two dynamical systems can be reformulated as an eigenvalue problem. This is one practical example where critical point of ARMA and LTI model are nothing but they are the eigenvalue of the original problem. So, we construct block matrix capital A, capital B, see, consisting of the coefficient matrices of the original matrix polynomial, and so W can be split into Koneca product of X, and we consider the limit matrix polynomial similar to definition 2.0, and we prove that this linear matrix polynomial
আচ্ছা খিদে পেলে খাবে তাহলে
so
ঠিক আছে চলছে এখানে ভাত খেয়েছি তো ভাত
we consider
দিয়ে শুক্তো দিয়ে
it is proved this
ইউনিভার্সিটি
of the R lambda mu. This proof I have
হ্যাঁ এই বোধহয় 7টা পর্যন্ত চলবে যাবো
theorem we have
ঠিক আছে হ্যাঁ
as per this like this, and v lambda in matrix u lambda is seen that the determinant is 1. Similarly, in case of v lambda, we have seen that block diagrams are identical also having determinant. That means we have constant determinant, and that is why for using this to we can construct this linearization class. So we have taken example to show that the form of linearization class. So here we consider the example by taking n equal to 2. So predicted matrices are like this, and we have constructed the lambda. We have seen that the size of the linear matrix polynomial, the coefficient matrices size increases. This is the problem. So here the u lambda and u lambda, L lambda, V lambda, this multiplication will become R lambda, block matrix consisting of R lambda, lambda mu. And we call it standard generalized linearization. This linear matrix pencil L lambda mu, we call it standard generalized linearization. Again, the standard generalized linearization satisfying this properties, that means L lambda into W, it represents matrices. That is where these elements are block matrices like R lambda X. 0 is the matrices of X. And again, and if we replace X by the identity matrix I, then we get this function proton type L lambda comes Koneca product n equal to E1. That is this is the first identity matrix IN, and that is called first base matrix, and this matrix equation to find more such D, more such RB satisfy the linearization class. For the find such type of vector, non-zero vector, is a special space, we call it answer space or input answer vector space. So with vector space 5.1 by considering and another linear vector space L R lambda mu satisfying this condition of equation 5.1, and it is represented by equation 5.2. And it can this statement 5.2 is not non-empty because the standard linearization L lambda mu with space that is non-empty, and it can be from that 5.2 represents a vector space, and the vector satisfying answer vector. It satisfies this if we multiply this v from left hand side we call it right subspace, and if we multiply from the right side we call it left hand subspace. So now we use the concept of box addition to find an equivalent vector space. If we add the box block matrix A, B, and C, then we finally get E1, that is the first column of the into this coefficient of the sequential order, and we develop an lemma one for rectangular plus, then this linearization plus satisfies the equation 5.3, and it can be put some also well satisfied. That means the vector space consisting of those vectors satisfies the equation 5.4. That means this box addition is well known. We can construct such linearization class using this box addition. Now we have finally showing if R is a rectangular polynomial as powered given equation, then we have a class that is L lambda mu is of order T by T n by K for the subvector space V, which is of the form L lambda here. If take CR, C take the form, and here this Y Z1 I do take this box matrices. Okay, that means here in this matrix and Y21 this is Z11 is individually matrix. Okay, it is a block matrix in next using it is this set BR, that is isometric secute C to the power 3, and consequently applying this product 5.1, and the dimension of the vector space is 9m3. So now the question is under some class current the condition to be satisfied such that L special rectangular quadratic it is seen not because if some condition, and therefore our focus is to determine whether from L lambda is a valid function or not. That means this demand the derived that you need to be matrix pencil to become a vehicle to outline to you. This is our
ঠান্ডা লাগছে এখানে বসে একটু
for that we develop a theorem 5.2
তো এখন বাইরে গরমে থেকে থেকে এসির এতটা ঠান্ডা
matrix polynomial as our given equation, and
না
for the answers would copy alpha 1, alpha u1, the
আর
linear
ব্যাটারি
polynomial
হয়ে গেছে
a
চার্জ
plus
দিতে
lambda b
হবে
plus
তো
mu
না
c
আচ্ছা
of
ইনি
order
কে
tm where this matrices a b and c
দিচ্ছে
takes this form like this
ডিব্রুগড়
this facts are
ইউনিভার্সিটির
already proved in our previous theorem, and where this y1 y2 and z1, these are the matrices occupying the column space, and then such that this y matrix, capital Y matrix, that is y2 to y21 and y3 to and y31
চার্জারটা
is
আনো
of full rank.
ল্যাপটপের
If this matrix is of full rank, then L lambda mu is a linearization of R lambda mu.
the edited version of the text
So now, how
Grammarly software
তোমার ল্যাপটপ আছে না ইসের চার্জার আছে
ল্যাপটপের হ্যাঁ
এইচপি ডেলটা কি
so it
কিসের লাগিয়ে তো লাগিয়ে তো
dimension of the original
এখানটা কোথায়
ওই তো ওই তো
now
এটার
question is
আনো
that
নেই
whether the
এটা আমার
eigen
laptop না।
information of the original
সবাতে
two-parameter
নেই?
polynomial and the linear expression
যেটা
are same or
নিজেরই
not.
ভালো
Obviously, this is
এর
same.
কম বেশি
Because
থাকে পাওয়ার
these two linear version
আচ্ছা
and original
তোমাকে
problem
অথার্স
are the
কমিটমেন্ট
eigen
ফর্মটা
information.
ফিল আপ করতে হবে
So,
কনফ্লিক্ট অফ
at least
ইন্টারেস্ট আর্টিকেল
it can be put
হাই
this rectangular
ভগবান
problem
কি করেছে গো ট্রানজাকশন এন্ড ফাজি সেট সেন্স সিস্টেম জার্নাল
as at most
ট্রানজাকশন
into twice n minus
এই
1
তো জার্নাল ট্রানজাকশন অন ফাজি
So this
সেট
has already
সেন্সেস
been put
আমি এই জার্নালে
in
পাবলিশ
theorem
করেছি
3 of
বহুত
another
পাঁচ
paper.
দ্বারা এদের
Now we try to recognize the eigen
দুটোর বেশি
by
পেপার
solving
একটা অথারের সাইট করা চলবে নি
আচ্ছা
আবার একটা জার্নালে
if we
দুটোর বেশি
multiply
পেপার সাইট করা চলবে নি আরে আমার এইভাবে কমে 30টা
equation 6.1
টোটাল
ষোলোটা জার্নাল এ হয়েছে
already we know about the matrices A, B, and C,
পনেরো
these facts
ষোলোটা
are the
রেফারেন্স
matrices. And if we
তো অনেক
multiply
ক্রাইটেরিয়া তো
the
বহু
equation
গাইডের ওদের বহুত
6.1
আবার তিন
পঞ্চায়েতে
না আমি তো দেখলাম যে তিনজন অথরিটি থাকে কোনো পেপারে
from
তাহলে তিনজনের নাম দেওয়া যাবে না দুজনের নাম দিতে হবে
না না ওরকম ব্যাপারটা
the
না
sub matrix can be generated by conventional
চার্জার দাও
example Gram-Smith norm orthonormalization process. We can develop such
করা
type of
আছে।
matrices. If we multiply this 6.1
আচ্ছা, ঠিক আছে।
6.1 by 2 matrices, then this
হোক।
induces a linear two-parameter eigenvalue problem
আচ্ছা
consisting of two
তোমার
equations.
edited
Now
version
two equations,
তুই
and now we can solve it.
একটু
Now this is a well-known general linear two-parameter eigenvalue problem. So this can be solved
edited version
by
of the
in
text
MATLAB
of the
already
article
in
by
MATLAB
Ramaswamy.
and well-known multi-parameter eye package. This is available in MATLAB. That means in online we can install it and can solve it.
আমার
And
দিকে লগ ইন করতে হবে
finally,
বললে তোমার ওই টেক্সটের কাছে
the whole procedure I have summarized in the algorithm form.
করে নেবে
So first, the
তাহলে
input
হয়ে
is the
যাবে।
coefficient
কারেকশন
matrix
তো
and
এমনি করা আছে
conversion.
চ্যাটজিপিটিতে তো
This will be given.
কারেকশন তো করে
চ্যাট
And
জিপিটি
first,
না
our aim is to find
তুমি কারেকশন গ্রামারলিটাতেই করবে অর্কিড আইডি
complete
সব অথারের
ওটা
আর
কিরকম দেবো
then we
অর্কিড
have to find
অর্কিড
two
আইডি তোমার
matrices
আছে
আমি
তো?
তো সেই মেইন জার্নালের
then we have to solve the
ফরম্যাটে
linear
সেখানে
two-parameter
অর্কিড আইডি
eigenvalue
আছে
problem
আমি সেখানে এডিট করেছি
presented
আবার
in
কি
equation
আলাদা করে ফাইল
6.1 and
পাঠাবো
6.2.
আলাদা করে দিয়ে দেবে
কি ওয়ার্ড
Here's the
ফাইলে
problem.
দুজনের মানে অর্কিড
So,
আইডির নাম দিয়ে দেবো এরকম করে
হ্যাঁ
নাকি?
ওখানে অর্কিড
finding
আইডি
solution
দেওয়া আছে
of all
ক্লিক
linear
করে
two-parameter is not easy. Because linear two-parameter eigenvalue problem cannot be solved directly. Again, we convert it into a system of joint generalized eigenvalue problem. That means we
সুমনা
convert
বলছে
it to an
ইয়ার্কি করছে
eigenvalue
ও
problem
মিউট
with
করা
form
আছে
Ax equal to lambda bx. If the problem is non-singular, based on the structure of the matrix, if problem is non-singular, then we can implement MATLAB code. But if this problem is singular, then again it gets problem. But limited two, three methods are available. One is based on Doran's staircase algorithm, and another some linear combination technique has been used to solve it. So this is again a problem. Therefore, resource is required to prove this singular case. And this code, MATLAB, this algorithm we have implemented in MATLAB. I have used the MATLAB version R2024A in the environment Windows 11 operating system. So if we use the high performance computing system, then we get the result more quickly as compared to my version, which I have used. So for to show matrices are used in example 1, that these matrices are generated using the MATLAB command in MATLAB, and we execute, and the results are given in table 7.1. How much time I have? 5 minutes. Okay. So next you are in, so in the idea rectangular total exponent is used to obtain the optimal least square for Arman and LTI dynamic. It is already, these things I already told that these critical points are eigenvalue of this associated problem, and the governing equation of LTI Arma P2 equation 7.1, where these vectors this yi belongs to R, this and I from 1 to n denote the sequence of n times its data points that may be influenced by noise, and we have considered this alpha naught and gamma naught as one. And but the researcher who proved that this this polynomial consisted of eigenvalue problem generated matrix polynomial with eigenvalue that is critical values, and we have considered the same problem considered by Bardi Moore, and this coefficient matrices takes the form like this. And this computed eigenvalue are shown in table 7.2, and only real is required in this analysis. Only real part is required, and we have considered the real part also only. And this has been this figure is plot, and this red point red star indicates the critical point of the eigenvalue with contour plot of norm of E square. This is the arrow function. In example 3, examine the system. The objective is to determine the parameter alpha I that yield the optimal approximation of a given vector in the sense of two norms such that satisfy the difference equation given in equation 7.3. So this reference type provides detailed outline of optimality conditions for minimizing, and we have considered the same problem 19, and here this Sn capital R and S matrices are the first R matrices is tridiagonal with stencil. Stencil means this is the matrix consists of diagonal, subdiagonal, and superdiagonal is 1, and all other elements are 0. Similarly, S is pentagonal, where subdiagonal and superdiagonal, including diagonal is 0, and above subdiagonal element and below superdiagonal element are identity, and all other elements are 0. And we computed and presented in table 7. No need, I'll explain. So this contour plot I have shown in figure 7.2. And yes, here this red star alpha gamma belongs to minus 10 to 10 we have considered. So, and finally we come into conclusion. We provided a generalized linearization framework for rectangular two parameter eigenvalue problem of the size m by n, and we have considered it tall matrix. That means m greater than n, giving us restriction m greater than n. Therefore, there's an open question to find this linearization class for any arbitrary matrices of size m by n. The eigenvalue problem associated with rectangular quadratic two-parameter eigenvalue problem we also address by developing algorithm that recover the eigenvalue of the original problem. So two dynamic we have considered as practical example. The vector rectangular quadratic two-parameter matrix polynomial are also addressed. So we in our future study, we intend to investigate the process derived from the defined vector space formulation for the coefficient matrix of size m by n without any restriction, including those for structured matrix polynomial in our upcoming article. One thing is that since uh, new technique has been worked at work for classical eigenvalue problem and generalized eigenvalue problem, but these things till now has not been explored in the literature of polynomial eigenvalue problem. So therefore, these things we need to be taken care of in our further discussion. Okay, if you have any question.
জার্নালের নাম বলো না, তোমার কাছ থেকে সেই জার্নালের
So
নাম
these are the references.
আমি সেই
Thank you, Dr. Bora, for his nice presentation. And first, I invite from offline audience if there are any questions, queries, or suggestions.
Okay.
Hello. Okay. In your presentation, you have mentioned that if you have singular matrices, that may create some issues, like non-singular and singular.
Actually,
Yeah.
singular matrices on the original problem does not create any problem.
Yeah.
The problem is the singular.
Hmm.
Due to the existence of one zero block matrix in the linear pencil.
Yeah. So my query is
And
that.
this singular problem, this linear two-parameter problem will convert it into joint generalized eigenvalue problem to solve find a numerical solution. In joint generalized eigenvalue problem, a problem of the form ax equal to lambda bx. If a problem is singular, this is singular. Then that means we cannot take the inversion of the
Inversion,
matrix,
yes.
and it will create problem in to find all possible solution due to existence of null vector in the problem.
Yeah. It just came to my mind that we have a concept called generalized inverse.
Yes.
Right, yeah. Can you deploy that thing in there?
So generalized inverse technique, if we use the generalized inverse technique, so this basically used in rectangular matrix. In the rectangular matrices, so yes, size problem is there because that is why I have considered tall matrix.
Solve matrix, yes.
Special condition I have given.
Yeah.
The m greater than n. If m greater than n, then means we will try to deal this matter.
Yeah. Thank you. Thank you for the response.
Any another question or query? If not, I am now inviting any question, query, or suggestions from online audience. So,
Announcement. I have an announcement from the Bora University. Actually, we know that this already, Mangal sir already informed you that this program is organized jointly by Department of Mathematics, the Bora University, as well as the Vidyasagar University, which is a reflection of the memorandum of understanding between the two institutes. And we are also organizing a conference on global trends in mathematics and ethnomathematics, both pure and applied perspective, on the month of November 19 to 21. The last date of abstract registration is 31st August 2023, and the early registration is 30 September, and paper submission deadline is 20 October. And please join us in celebrating the mathematics across culture. Okay, and this conference is sponsored by NRF, and hope sir will bring a team from this institute. Okay, thank you, sir.
Thank you for your invitation. Now I'm requesting this organization, this chairperson, Professor Dr. Murumangal Pal, I am requesting Dr. Sukumar Mandal sir to confer certificate to Dr. Bora. Now it's that tea time, right? So I'm handing over this mic to.
So today's invited talk and keynote speaker, the lecture by keynote speakers. Today's